Hey guys, I'm not very sure why my camera is not working, so I'm just going to go ahead and um, try this video without that. So just kind of bear with me. All right, so we are looking at net ionic equations today. And by the end of the lesson, you should be able to analyze the law of conservation of matter and how it applies to different types of reactions. This is really looking at double displacement reactions, so you may want to review predicting products for those and writing ionic formulas before you get started. So let's talk about the steps to writing net ionic equations. If the products are not already given to you, so in the examples we're going to do, they are not, you have to predict them. So if they're not given, make sure you predict the products using the solubility rules in your reference packet. Make sure you also include state, because for double displacement, especially net ionics, we need to know which compound is a solid. You're going to then write the complete ionic equation, which is where all aqueous compounds are broken up into their ions, but then your solids will stay together. For this, actually, your liquids will stay together and your gases will stay together. So basically, anything that's aqueous will break up. You're then going to cross out the spectator ions. So the spectator ions do not participate in the reaction. I like to compare this to being a spectator at a sporting event. If you're a spectator, you're sitting in the bleachers watching the event. Spectator ions are watching the chemical reaction take place, so they are not actually participating. So we cancel them out because they do not change in the reaction. Once you do this, this leaves you with your net ionic equation, which is just the reactants that change and form into a new product. And then make sure to balance with respect to mass and charge. So this is just balancing the equation like normal. So we're going to go through this example together, and then you are going to try the one that comes after. And I will say the one that comes after, really pay attention to charge. Okay, that's very important. So let's look here. I've given you the formulas for our first two compounds. So we have NaCl plus, and we know that's aqueous because we're looking for net ionic. So our reactants have to be aqueous. And then if you remember how we do it in class, we're going to partner our inners together and partner our outers together and write our formulas. Remember that Na is a +1 charge, Cl is a -1, Ag is a +1, NO3 is a -1. So these will be easy partnerings. We don't have to crisscross or anything there. So when we do that, we're going to come up with first NaNO3 and AgCl. So then once you have your products, you have to, like it says, include the state. So you might have to use your solubility rules to help you with this. If you look at your solubility rules, remember we rely on these second elements to tell us the rules. So the one for nitrate says all nitrates, ammoniums, group 1A salts, there's one other one that I can't remember off the top of my head, are soluble. Well, we've got a nitrate and a group 1A salt, so that one is soluble. You always want to check both, though, because sometimes they may try to trick you and give you two aqueous at the end to know that that's a no reaction. But here we're looking at a chloride, and that rule is all chlorides, bromides, and iodides are soluble except for silver, lead, and mercury 1. So this chloride is partnered with a silver, so that will be your solid here. Now that we know that, we need to take all of these aqueous and we are going to break them up into their ions, kind of like what we did up here, but we're going to write them all together. So this will be known as your complete ionic equation. So we're going to have, let me pick a different color. We know Na and Cl break up into Na plus and Cl minus. Ag and O3 is going to break up into Ag plus and NO3 minus. So we just literally broke them up into their ions. We're going to make sure to put AQ with all these. And now we're going to go to our product side. Since NaNO3 is aqueous, we're going to break that one up as well. Both of those are aqueous. And then AgCl is solid, so it has to stay together. It does not get to break up. This is our complete ionic equation. Now what we have to do is we have to pay attention to ions that are the same on both sides. One of those is Na, so Na plus, as you can tell over here and over here, look identical. So we're going to mark them out because if they show up on both sides of the arrow, we can cancel them. The only other thing that shows up on both sides of the arrow is NO3 because Ag and Cl are separated on the left but together on the right, so they do not cancel out. So once you do those, you can rewrite this as your net ionic equation, and I would always write the positive ion first followed by the negative ion on the left side just for practice. And once you write this, just make sure to balance with respect to charge. Remember that an ionic compound wants a charge of 0. Well, we've got a +1 and a -1 here, so they cancel to give us 0. So in terms of charge, we are balanced. And mass, that's like balancing like normal. So we have 1 Ag and 1 Ag, 1 Cl, 1 Cl. So we are balanced with respect to mass as well. So now, guys, I want you to pause this video and try this example, and then we can go over that in class as well.